Hello students, today we're looking at 5.6, which is graphing inequalities in two variables. You did an activity with this, and so I just want to remind us of a couple of things that you might want to write down, or if you've already written it down, you can just transfer it over. The first one is when we are graphing an inequality, we want it to be in y equals mx plus b form. We have to have it in that form before we can graph it, and the equal sign is going to be an inequality statement, but we still need the y, the mx, and the b in order to do that. If we have less than or equal to or greater than or equal to, the line will be solid. If we just have less than or greater than, then the line is dotted. Okay? If we have less than or equal to or less than, we shade below the line. If we have greater than or equal to or just greater than, then we shade above. Okay? And one of the most important things is a solution is any point in the shaded area. Any point in the shaded area can be a solution to the inequality. Okay? Those are the pointers, those are the hints, those are the things that we need to remain aware of, and now we're going to graph a couple. So here's the first inequality that we need to graph. It's given to me as x plus 5y is less than or equal to 10. Well, the first thing I notice is that I don't have it in y equals mx plus b form, so I need to do that first. So now I'm going to do that. So I'm going to move x to the other side. So I get 5y is less than or equal to negative x plus 10. And then I need to divide everything by 5. So then I get y is less than or equal to negative 1/5 x plus 2. And now that I have y is less than or equal to negative 1/5 x plus 2, I can now use this information to graph it. So I know from the less than or equal to that I'm going to have a solid line, and I'm going to shade below. Okay? So the first thing I will do is graph my y-intercept. My y-intercept is 2. There's my y-intercept. My slope is negative 1/5. So I'm going to go down 1 and to the right 5. And I can go down 1 and to the right 1, 2, 3, 4, 5. Or I could go up 1 and to the left 5. And there I have my line. Now, it's going to be a solid line, and I need a ruler. Just happen to have a yardstick here, so let's draw this line. See if I can get it anywhere close to what I need it to be using this marker. Okay, solid line because it was less than or equal to. And then it's going to ask me where do I shade. I'm going to shade below. Now here's the deal. When you're shading these lines, I don't need you to color and everything. I just need you to put squigglies that let me know we're shading below. That's the only thing we need to do. Draw a few squigglies, let me know we're shading below. Now let's look at a couple of solutions. Is the origin a solution? Absolutely, because the origin is in the shaded area. And if I plug in 0 plus 0 is less than or equal to 10, it does work. So I can verify with my inequality statement, or I can verify by looking on the graph to see what all my solutions are. The next example I want to graph is 3x minus y is less than 2. So I first of all notice that it's not in slope-intercept form, so I need to do that. So I'm going to bring the 3x to the other side, and I'm left with negative y is less than negative 3x plus 2. Because the 3x, I'm subtracting 3x from both sides, I move it across, it becomes negative. Okay? Now I've got a negative y. I can't have a negative y. I need a positive y. So I either need to multiply or divide everything by negative 1. So I'm going to just divide everything by negative 1. It's easier to write it that way. So negative y divided by negative 1 is positive y. But I'm divided by a negative 1 on both sides. That means I need to flip or change the inequality symbol to greater than. That's very, very important even in graphing. If I divide by negatives on both sides, I have to reverse the symbol, okay? So then negative 3 divided by negative 1 is just simply 3x. 2 divided by negative 1 is minus 2. And now I have the inequality statement, y is less than 3x minus 2. So what can I formulate from this? Well, I've got a greater than, so I know it's going to be, the line is going to be dotted. And I know that I'm going to shade above because it's greater than. So now let's do this. So I'm going to find my y-intercept first, which is negative 2. So I plot the negative 2. And then I have a slope of 3, or 3 over 1. So I go up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. And there's my line. Need to draw it. Here's where you got to remember, it's got to be a dashed or dotted line because there's no or equal to. So let's see if I can get it on the correct points. Dash, 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 dash. It's not the most beautiful dashes, but they're dashes. So now I have a dashed line on y equals 3x minus 2, and it says that I need to shade above the line, so that's going to be on this side, because that's above. Now let's test it just to make sure. 0, 0, the origin is still on the shaded side. So let's plug in and see if that works. 0 minus 0 is less than 2. Is 0 less than 2? Absolutely, so I shaded the correct side. So all of the solutions are in this shaded area. Now, is 1 comma 1 a solution? It's on the line. The answer is no, because the line is dotted, so none of the points on the line, on the dotted line, are solutions. Only things, in this case, above the line. So here are your practice problems tonight. There's just 2 of them, and I am so sorry that you may or may not have graph paper to do these on, so just draw a coordinate plane and do the best you can, because the big deal is the line solid or dotted, and the other big deal is, do you have your y-intercept in the right place and such, and the shading, okay? So number 1 is x minus y is less than or equal to 3. And then number 2 is 2x plus 3y is greater than 18. So these are your 2. You first of all have to put it in slope-intercept form, then graph the line, draw it either dotted or dashed, and then put the shading in the correct place. Once you have those done, take a picture and submit it to Edmodo.